Good afternoon, ladies and gentlemen. First of all, I would like to introduce the group of researchers from Batumi State Maritime Academy, and the group consists of the following academic staff: Professor Maia Tugushi, Professor Zaza Shugladze, Professor Gocha Gogitidze, Professor Madonna Loria, Professor Firuza Varshanidze, Professor Guram Putkaradze. And all these researchers, they present the following results on the topic hydro-discharging chamber kinematic systems and perspectives of their application in electric drives. The efficient control of high-voltage power plants is one of the most important tasks both in maritime and shore-based power systems. Application of hydraulic systems turned out to be efficient in the power plants of variable load and high voltage. This gives universal opportunity to convert mechanical characteristics of driving engine in accordance with law. It is also easy to control and protect engine and executing sections from overloads. Electrohydraulic propulsion device, electric engine pump, and hydraulic transmission system, in comparison with electromechanical gears, is distinguished for reliable operation during fluctuation of number of revolutions from 1 to 4 revolutions per minute to 2,500 revolutions per minute by high power value transferred to unit of mass of the propulsion device. But hydraulic power ring has also some disadvantages that are first of all revealed in the pressure losses during long-distance energy transfer. In order to keep the pressure and the moment, several power rings are used in such systems. Increase of the number of central rings causes decrease of efficiency. This disadvantage may be corrected by creation of high power ring near actuating mechanism. That would cause decrease of central rings in the above-mentioned power system. From this viewpoint, it is necessary to consider application of electrohydraulic effect. Since 18th century, mechanical damage of the surrounding objects resulting from the electrical discharge in water became the object of study of scientists. The effect received by high-voltage pulses in water was called electrohydraulic effect, and the research works of many scientists were dedicated to this effect. Primarily, it was thought that mechanical effect on the surroundings during power discharge took place only on liquid dielectrics. However, in liquids having ionic conductivity, it is spread only on short distance and is characterized by excessive production of gas and steam. The area of spreading of streamers resulting from the effect of electrohydraulic blow is dependent on the properties of the liquid and the parameters of high-voltage pulse. Discharge also results in creation of cavitation that causes sharp fluctuation of ambient pressure due to its expansion and compression. The electrohydraulic blow may be observed as a result of the given phenomenon. The scheme of pressure spread in the discharge channel is determined, which is shown in figure. Number 2. Different values of received pressure correspond to different values of air jacket thickness created during discharge. As it can be seen from the figures, maximum pressure can be received near to the surface jacket of the discharge channel, and its widespread is dependent on the properties of the liquid. Pressure value can be determined by the following formula you now see on the screen, where P is pressure received in the discharge channel, the second P is 0 atmospheric pressure, B is a liquid characteristics constant and firm. The P is density of compressed liquid received by the effect of plasma channel during discharge, and P0 density of liquid in normal conditions. A stands for the constant of the liquid, and its value for water is 7 and 15. 3 general modes of electrohydraulic discharge are known. These are hard mode with the following parameters, average mode with the following parameters, and soft mode with the following parameters. As a result of electrohydraulic effect, the area of widespread of streamers in liquid depends on liquid properties and high voltage pulses parameters. Discharge is followed by creation of cavitation pocket with expansion and compression that are followed by sudden pressure variation in the environment or atmosphere. The result is formation of electrohydraulic blow. The research describing the effect of forces resulting from electrohydraulic blow on the propulsion device is discussed in the present report. Fresh water with temperature ranges from 18 to 23 degrees Celsius and is used as a working liquid in this experiment. During electrohydraulic effect, the received pressure value reaches several tens of megapascals. On the laboratory stand, the values of forces influencing cylinder piston with several megapascal pressure have been revealed. Tests have shown that by moving piston it is possible to move or shift cargo of 90 Newton rate. The pressure values received during electrohydraulic effect are commensurable to the pressure values received during the present experiment. It is the issue of interest for researchers to see how efficiently can the received pressure be used for shifting, moving, or driving the objects. As the plant should be near the user, the tests were implemented during non-standard working mode with parameters given here. Cylinders of different sizes made of various materials have been fabricated, and also the components for connection to rotating wheel given in figure 1.7. As sizes of sliding bar, connecting rod rocker were changed during tests, the approximate scheme of the system is shown in figure 1. During operation of typical crosshead connecting rod mechanism, it turned out to be impossible to receive full revolution of the wheel. The reasons for it are the following. The frequency action of blow force received from electrohydraulic effect on piston significantly exaggerates the frequency of periodical movement of sliding bar and connecting rod. Disbalance caused by unbalanced rotating masses impedes formation of steady motion. Charging-discharging time of the condenser is not sufficient for complete piston stroke. Here it is necessary to take into consideration the friction forces induced between piston and walls of the chamber. In order to bring the friction forces to minimum, the piston diameter has been reduced. This violates the hermeticity of operating space of the chamber, and during electrohydraulic effect, vacuum is not created during liquid compression. The striking force on piston surface is also reduced. Based on everything said above, the ratchet mechanism has been invented that ensures the conversion of fore and back movement of the piston into unidirectional rotation. Where first is a ratchet wheel, second is ratchet pole, third is cylinder, and fourth is a piston. In picture 1, we can see fabricated power transmitting mechanism, spring-lock mechanism, and rocker transmitting mechanism. The rotating movement of tracking wheel is received in both cases. On the present stage of research, the number of revolutions of tracking wheel is n equals to 4 revolutions per minute. If tracking wheel with radius 0.145 meters is connected to shaft with radius that is 10 times smaller in comparison with the radius of tracking wheel, the number of revolutions will be increased 10 times. The conclusions. Two types of experimental models of power systems connected to high-voltage electrodischarging chambers have been created. Both models have disadvantages. They are insufficient hardness during discharging by striking forces created on the piston. Deformation of rocket and wear of connecting cloth takes place. Unstable value of cylinder piston movement that is resulted in non-standard revolution turn of the wheel. Despite the indicated disadvantages, it is possible to use the generated power in the discharge chamber to drive the transmission mechanism. In order to refine transmission mechanisms, gear system and optimum parameters of spoke wheel should be developed. Here you can see the literature used during the work on the present report. Thank you for your attention and all the best.